What's poppin', dogs? It's Mr. Allen with a couple examples of power theorems or product theorems in circles. They have a couple different names out there. This one is a chord-chord situation. I got a chord and a chord of a circle. Over here, I have a tangent secant situation. They have two different formulas. We're going to work through both. So for this one, the chord-chord theorem is the product of these two parts is equal to the product of these two parts, which is lovely. I'll have 6 times x is equal to 3 times 4. We'll work that all out. You could do 3 times 4 in your head if you'd like. That's going to be 12 divided by 6. Bingo, bango. We get x equals 2. That's it. Lovely. Easy peasy. All right. Now for this guy, which is a little more challenging. All right. I did plan it that way. We'll use orange for this one. So I have a tangent and I have a secant, right? A secant's going to go through a circle twice. It'll be going through there 2 times, whereas the tangent just touches at that one spot. Generally speaking, with circles, will allow you to assume tangency if it looks like it in the diagram, one of the few assumptions they'll allow in geometry. So this one, the tangent squared, so 6 squared, I'll write it here in the circle, that'll be fun. 6 squared equals the outside part, which is x, times the entire secant here, x plus 9. Okay. And now we got to math. We got to do a little bit of algebra for this one. I'll distribute my x in. I'll change that 6 squared to 36. Then we'll have x squared plus 9x. Uh-oh. What do I do now? Oh, no. Panic. It's a quadratic. Don't panic. We're going to set it equal to 0. Then we'll factor, hopefully, if it's factorable, or use quadratic formula. Got to bust out the big dog sometimes. But hopefully it's factorable. All right? So let's set it equal to 0. I'll subtract 36 to do that on both sides. We get 0 equals x squared plus 9x minus 36. Now, does anything multiply to negative 36 while adding to positive 9? Yes, it does. 12 and 3 would do the trick. So x plus 12 and x minus 3, that multiplies to negative 36 and adds to positive 9. Now, I can take my two factors, set them equal to 0. So x plus 12 equals 0 and x minus 3 equals 0. Or you might be like, bro, it's just the opposite, right? It is, unless you get a lead coefficient in there. Then you got to do a couple steps of algebra. So I like to write it out to remind myself the whole reason I factored in the first place was to get each individual factor equal to 0. Because if one of those is 0, the whole thing is 0, right? That's math, baby. All right, subtract 12. I get x equals negative 12 and x equals positive 3. Now, we have what's called an extraneous solution here. And I think it's easier to tell in geometry what an extraneous solution is than it is actually in algebra, even though they come usually from algebra, okay? An extraneous solution comes from proper algebraic steps. We solve this thing perfectly, but can I have a length of negative 12? No way, Jose, but 3 is Gucci, so x is going to equal 3. Negative 12 will not work in the original context of the problem. If my original problem was solve 0 equals x squared plus 9x minus 36, we're fine to use both. But it's a length in my problem, therefore it must be positive. Okay? So there we go, guys. 2 dope power theorems or product theorems, whatever you want to call them, which we know and love about our circles here. We got chord-chord, tangent, secant. There's also secant-secant. That's pretty cool. Maybe I'll do another video on that. Check it out. Otherwise, have a great day, and thanks for watching.